Okay, we get out of here at 23. If it is 2:20 and I haven't handed these out, it is redundant. Don't forget about the bullet sheet.
Don't forget. I don't forget.
So then yours has back. Okay, we're going to start chapter 2. Paxton can't see. Do I need to switch you guys back?
I can see worse now.
Guess we're
Wait, you just don't bet. I will talk a bit. Yeah, I can promise. And I never talk about.
Right. Okay, we are gonna start chapter 2, and chapter 2 is all about logic and proofs. If you can't hear me, that's a problem. Chapter 2 is all about logic and proofs. Okay. Yes, Jonah.
And I can sit.
And you think it's gonna be better for Emily if you switch?
Yes, because she's like, really like, her eyes are like better.
Let's just try it for today and then we'll talk. Okay. This chapter is going to be a little bit different. There is going to be a little bit of algebra. Okay, I need you to turn to page 36, people. 36, page 36. Okay, but in this chapter, we're going to be doing a lot of logic. We're also going to be writing proofs eventually. Okay, it is not a bad word. It is not something to be scared of. Okay, we are going to learn it together. We are going to experience it together, and we'll work through any issues that we have together. Okay, so the first thing we're going to learn about is what's called conditional statements. Okay, basically, we're just talking about logic here. Okay, so with your highlighter, once again, does this require any more noise? No, so stop.
I said senor. I said senor.
A conditional statement is a logical statement that has two parts, a hypothesis, conclusion. Basically, you could call these if-then statements. Okay? If the hypothesis, then the conclusion. Okay? So I need you to understand some notation here. So if P, then Q could be written like this. Like P, our hypothesis, with the arrow, this means implies Q. Implies, like, okay. If you got a 95%, that implies you got an A. Like it makes it true. Okay. Okay. So we're going to practice taking a statement and identifying the hypothesis and identifying the conclusion. So what I want you to do is write down this example number 1 right here. Do you see where it says notes right here? Okay, probably not with your highlight. Oh, no, you can highlight. Okay, so I have it big so we can see it on my board. Okay, go ahead and write down this statement. If you can predict the future, then you can control the future. Why does it keep moving? I don't know. I'm sorry. Just write where those notes, where it says notes right underneath, write this statement. Not too big. Just write it. Okay. Right now, we're just worried about what is the hypothesis, what is the conclusion. We'll worry about things being true or not true here in a little bit. Okay. So the hypothesis is what is going to come after the if. The conclusion is what comes after the then. So if you can predict the future, so I'm going to underline you can predict the future. That is our hypothesis. Okay. Then you can control the future. So I'm going to squiggle it. And that's our conclusion. Yes, go ahead.
Do you think time travel will be possible in the future?
I don't even want to think about it,
It
honestly.
won't, but teleportation will be possible, not time. Teleportation. Ow, ow. Teleportation. Not teleportation. Like in Minecraft, you teleport.
This is amazing. We went from geometry to Minecraft way too quickly there. Okay, now what I want you to do is write down statement number 2. And while you're writing down statement number 2, is it written in that if-then form? No. However, could we rewrite it so that it was in the if-then form?
Yes.
Okay. Okay, so I'm going to rewrite it. If, okay, so if, then they share a vertex, but what's in between? Okay, so if 2 angles are vertical, then they share a vertex. Okay, so now let's talk about the hypothesis versus the conclusion. If 2 angles are vertical, that's our hypothesis. Then they share a vertex. That is our conclusion. Now, let's talk about whether or how do we determine an if-then statement is true or false. Okay. So, if we have a conditional that is true, then we need to show that every time the hypothesis is true, the conclusion is also true. So basically, if our conditional statement is false, we need to show a counterexample. Okay? If something is not true, we need to show a counterexample. Like, for example, all odd numbers end in 5. What's a counterexample for that? Ben?
12.
That's not a very good counterexample because 12 is not odd. All odd numbers end in 5.
Odd, 13. I didn't.
Okay.
Odd part. Yeah.
13 would be a counterexample because it's an odd number that does not end in 5. Okay, we're on the same page now. All right. We are going to determine if these 2 statements are true or false. Okay. We're going to determine if these 2 statements are true or false. Okay. If 2 angles form a linear pair, then they are supplementary. Turn to your neighbor and make a decision.
Yes, sir.
Okay, eyes up here. Cohen, why is it true?
Because a linear pair is always supplementary.
Okay, it's like a part of the definition. A linear pair is always going to be 2 angles that are adjacent that add to 180. Okay. Now, what about this? If a number is divisible by 5, then it is odd. Okay. Now, if it is going to be false, then we have to provide a counter example. Who can give me, Layla, a counter example? 30 is divisible by 5, but it is not odd. Cohen. That is not necessary right now. All right. Now let's talk about negation. The negation of a statement is the opposite of the original statement. So basically, if we have P, the negation is not P. We're gonna add a not in front of it. Symbolically, we have this little squiggle. This means not P. Okay, so for example, the sky is blue. If that is statement P, then statement not P would be the sky is not blue. We literally just make it opposite. Not true. Or not necessarily true, but just we're saying it's the opposite.
So like, instead of saying like, the sky is green, it's like the sky is not, like, you just do the opposite.
You just like throw in the not.
And that was for the not.
Yes.
It's like when you ask.
I don't know what I said, but I think
Okay. His question was valid. He was asking me, do we simply put in another color to make it a not statement, or do we just put the word in not? And it's the second, we put not, okay? So there are 4 different statements that you need to be able to write. You need to be able to write a conditional statement. That's just if, okay? A conditional statement. Conditional statement. If P, then Q. All right. Now, if I ask you to take a conditional statement and write the converse, the converse is where we just take Q and P and we switch places. If Q, then P. So up here, I'm going to write a conditional statement, and then we're going to write the converse right here with it. So what is my, if the measure of angle A is 15 degrees, then angle A is acute. That is my conditional statement. Okay. Here is my hypothesis. Here is my conclusion. Okay. Now, if I'm going to take this conditional statement and write the converse, we are going to write if Q, then P. If angle A is acute, then the measure of angle A is 15 degrees. We're not talking right now about whether they're true or false. We're just taking a statement and we're going to rewrite it. Okay, now we took Q first and we took P second. Is that a true statement? Okay, so give me a counter example.
It could be
Could be 14 degrees.
89.
Okay. Okay, all you need is one counter example. Okay, just one. And guess what? We could all have different counter examples and all be right. Okay. There are a lot of different acute angles. Okay. Now, is this statement true up here?
Yes.
Yeah, that is true. Okay. All right, now let's talk about the inverse. The inverse is where we take if not P, then not Q. So we take them in the same order, if P, then Q, but we negate both statements. Yes.
Is the converse like all squares are rectangles, but not all rectangles are squares? Yeah.
Hey, we're gonna get there in a little bit, okay? I want a square is a special rectangle. Okay. Yes. You could have 28.3 degrees if you really wanted to. Okay, so let's talk about how we would write the inverse. Ladies and gentlemen, we're writing the inverse. We are writing the inverse. Face this way. Okay, Tyler. Okay, we're not gonna argue about it right now because he's not going to bush. If not P, how do I negate this? If the measure of angle A is not 15 degrees, then angle A is not acute. Oh, you have to put, okay, is a true or a false statement? Okay, I need a counterexample then. I'm listening, Cohen. But I don't think that that's a very good counterexample. Well, no, you're good. Hold on. What about 99 degrees? It's not 15. Nope. I'm going back to 16. Okay, so if the measure of angle A is not 15, then angle A is not acute.
Which then you have to do with
That statement just made no sense.
Okay,
Yeah, I know, but how are you gonna?
because I could talk about a lot of different angles other than 15.
That is cute. That are bigger.
So that's why I'm saying we should talk about like 92 degrees instead, because that's not acute.
Yeah.
It's not 15, but it's not acute.
So that's a
counterexample.
no, it's a right. Because it has to be not acute.
Don't we want to be not acute?
I mean,
Okay, hey, let's argue let's argue like in an organized manner. Okay. This is not 15. I need an angle that is not 15, but is not acute. Okay.
139.
But it's false. So you think it should be 16 degrees because it's okay. Stella, what would you like? Okay. Okay, why? Look at us arguing back and forth.
So if one proxy.
What? Yes.
That's why I'm right. That's just how it works.
Okay. Let's focus. Let's focus. Here is an angle. Hey, hey, hey. Here is an angle that is not 15 degrees, but it is acute.
Disagree. That's not.
Now he's on cute though.
Isn't it 16 acute?
It's not supposed to be cute.
Because I'm trying to make it false. I'm trying to make it false. Okay, we need to stop. We need to stop. We need to stop. I can't even answer people's questions because you won't stop talking over there. It's not just Ben, Keegan.
Talking at all.
Contrapositive. We're gonna come back to the converse when people, or inverse when people can handle it. If not Q, then not P. That is our contrapositive. So basically, we're taking the inverse and we're flipping it around. If angle A is not acute, then the measure of angle A is not 15. True or false?
True.
Yeah.
That's true. Yeah, though.
Doesn't matter because this is not Spanish. Okay, now here's a fun fact. I'm getting sick and tired of you guys not being quiet when I ask you to be quiet. Doesn't matter what the word is in Spanish. Fun fact, a conditional statement and its contrapositive are both true or both false. Also, the converse and inverse are either both true or both false. Did that happen here? Sure did. Conditional and contrapositive, the first and the last one, were they both true? Yep. The converse and the inverse, the second and the third, they were both false. Okay. 16 degrees makes this acute, which is false according to that statement. Okay. Are you with me? Okay. We are going to practice writing the different 4 statements of this right here. So, you know, where you have this little note right here, we're going to write 4 statements. Okay. Now, all birds have feathers. Does this look like it's in the if-then form? So we need to put it in if-then form. Okay. So our conditional, if it is a bird, then it has feathers. Are you writing this? Because that's what you should be doing. If it is a bird, then it has feathers. Converse means we're going to switch P and Q. So if, Cohen, what's our if?
That's true. Does a penguin have feathers? Yeah, penguins are birds though.
Yeah.
But still, like they have like.
Do you know of a bird? Do you know of an animal that has feathers that's not a bird? Dinosaurs don't count. Colin. Dinosaurs don't count.
What's it called?
All right, the inverse. The inverse. Jake, what do you think the inverse would be? I'm listening to Jake. You're listening to Jake.
Sorry.
So we're going to negate P. Here's P.
Is chicken a bird?
So the inverse is going to go in the same order as the conditional. If it is not a bird, then it does not have feathers. Okay, so this is what I would do. If P then Q is our conditional. Converse, if Q then P. Inverse, not P implies not Q. And so our contrapositive, not Q implies not P. So now I'm going to come over and I'm going to, okay, what's my Q? What's my P? Remember, a bird is P, has feathers is Q. So my contrapositive, not Q. If it does not have feathers, then not P, it is not a bird. Okay, if you did not write these cute little symbols, go ahead and write them now next to conditional, converse, inverse, contrapositive. And when you do your homework tonight, I want you to write these cute little symbols. That way you get in a rhythm of what comes first, what comes second. It's pretty easy to get a statement switched around if Q then P, if P then Q. Okay, it's easy to get things a little backwards. Okay, so the more you write those as you're doing your work, the better it's going to be for you. Yes.
Why is it like P and Q?
Why is it X and Y? I don't know. Okay. All right. Now, a biconditional statement is one that is an if and only if. Okay. If P, if and only if Q. And notice how the arrow goes both ways. That's because if it's a biconditional statement, then we could say P implies Q and Q implies P. Okay, that is what that means. Okay, if and only if means you can read it both the conditional and the converse, and they both are true. Okay. For example, a segment, we're not going to worry about this one. Well, this one, okay. A segment bisector cuts a segment in half. So let's write the conditional statement. Okay. If it is a segment bisector, then it cuts segment in half. Is that true? Okay, so now let's write the converse. Gold sheets. Yep.
Hey, we have 5 seconds left. I'm the one that's telling you.
Okay, so P then Q. How about if Q then P? If it cuts the segment in half, then it is a segment bisector. I'm abbreviating. Thank you, Tyler.
Yep.
Hey, is this your statement?
Yes.
Okay, so if we can write if P then Q, and it's true. We can write if Q then P, then it's true. Then it's a biconditional statement, and we can write if it is, oh, let me,
Why means like.
okay. It is a segment bisector if and only if it cuts the segment in half. Okay, we can read it forwards and backwards and it is still true. Okay, so tomorrow
Wasn't your job.
it's gonna be such a hard day.
Wait, why?
Because I don't get to see you.
How's good?
Woo!
Whoa.
Oh,
no,
Matt,
Matt,
Dog. Oh, I even knew
So,
that.
you have listened to me. I will keep you up to the bell.
No, thank you.
Yeah,
Then
I know.
be quiet. You have a book assignment that is in Google Classroom and the answers are in there. Shut up and stop moving. You have a book assignment in Google Classroom. I can't even hear myself talk. Stop moving. Just stop. This is ridiculous. You have an assignment in Google Classroom with the answers in there. Now, you can work on that during 5th and 6th hour tomorrow. But if you need more to do, I have a fun little Desmos challenge for when you're done with your homework that you can work on. It'll be in Google Classroom tomorrow. It's like a laser thing that you can like adjust the angles for your laser beam. I gave you the gold sheets. You didn't even take them. You can pack up now. Thank you, Tyler.
I like to do that.
Yes.
I'm free. It's
No,